So the question asks about basically two boxes that are on an inclined plane of 20 degrees. So the boxes here are A and B specifically has a lower coefficient of friction, which means that B is going to end up pushing on A for A to kind of go down along with a component of gravity. Um, so the question wants to know how long does it take package A right here to reach the very bottom of the ramp? And there are few kind of big ideas or learning goals of this problem. One such learning goal is the idea of free body diagrams, which basically show all the forces acting on a specific object within the system. Another big idea in this question is the use of Newton's third law. And this is basically the idea of how there is an opposite reaction uh, for every force, and they are equal in magnitude and opposite in direction. And finally, one big idea of this problem is the idea of inclined plane forces, um, where basically mg has a component that's pushing something down the ramp, and also normal force is not pointed straight up. So here we can see a free body diagram of A, where there's a normal force from this kind of ground. There's the frictional force pulling against it, and there's a normal force from block B, and there's the gravitation right here. And B has a very, very similar force diagram here, except the normal force on B is A pushing back against B, and that's the main difference between the two. So, to solve the problem, we need to think about summing the forces. So, to sum the forces, we have block A and block B. Um, Down here is A, up here is B. So we know that mg sine theta is going to be basically the component of gravity that pulls both of them down. And we know that mg cos theta times the coefficient of friction is kind of the component that is pushing against them, and that's friction basically. And then here we have the normal forces, which are equal in magnitude but opposite in direction, as we can see here. And basically, this will allow us to cancel out the equations. And here we know that force equals mass times acceleration. So the force is all summed up into ma, with one being the mass of B and one being the mass of A. Now, doing a little bit of algebra, we can just add the equations together, which allow us to just cross out the ends and do some beautiful algebra. So we get this equation here, which we can plug values into and solve for the value of acceleration. So doing a little bit of number crunching, the acceleration value comes out to be 1.66 meters a second squared. And basically using our kinematic equations, with this one basically being d equals d initial plus vit plus 1/2 at squared. And of course, the initial velocity is 0, so that isn't really applicable. The initial displacement is also 0, so that isn't applicable. So this is the 1/2 from the equation. It's the acceleration, and this is the time squared. So doing more algebra here, we can isolate for the variable t and get the seconds it takes for the boxes to slide down the ramp, specifically block A in this instance. So there are a few common mistakes with this question. For example, not realizing that the normal force is not not quite shared, but that they're equal to each other and opposite in magnitude. So they're basically the same value, except opposite signs. And the other problem is that you don't see that block B pushes on block A, and that would turn out to be a totally different question, with a different answer. All right, thank you.